Welcome. In this, I will be talking about finding the lateral and surface area of the following objects. Here, we're looking at a equilateral prism. This problem is very easy if you can break it up into two pieces. Okay, the surface area, SA, is made up of the area of the base plus the lateral area. The lateral area here is very easy because it is just made up of three rectangles. The rectangles are easy to solve because the rectangles are defined just by length times width. We can do that easily because the length here is 6 and the width here can be 12. So it's very easy to compute this. And we have it here as the lateral area is 216 centimeters squared. The issue is the area of the base. There's multiple ways you can do this. You can approach it in two ways. You can say it is made up of two equilateral triangles, or you can say it is made up of, or you can say it's made up of four right triangles. Okay, I'm going to show you the equilateral triangle one right now, and we're going to see how that works. You would need to know the formula for the area of an equilateral triangle. That is defined by the square root of 3 divided by 4 times a squared. A is represented by the sides of the equilateral triangle, which in this case is 6. So when you make the substitution in, it should look something like this. Square root 3 over 4 times 6 squared. Okay, and now you can compute this out. Here I brought up decimals to show it to you. The square root of 3 divided by 4 times 6 squared is going to be the area of that equilateral triangle, which is 15.588. That is the area of that red rectangle. Multiplying by 2, because we have two of them, we get that it is roughly approximately 31.78 centimeters squared. This is the area of this equilateral triangle. That's one of them, and then the second one is there. Remember, that 2 is because there's two of them. Then you add 216 cm, and you are now going to notice that the answer, let's do that, plus 216. And let's look at that answer. Okay, I did it in my calculator just in case, and I got 247.18. We can say it's approximately 247.18 centimeters squared. This is if you look at it from a equilateral triangle point of view. However, there is another way of doing it, because this equilateral triangle can be seen as if I split this in half. Let me clean this up for you. I can split this in half, and I can show you that it's really one right triangle. There you go. That right triangle that it is referring to, now you can compute to get certain things, because this is a 6. This, once it's split, it becomes a 3. It's very easy to do this because you know what this formula is. You've done it before. A right triangle is defined by just 1/2 base times height. In this case, I'm just using A and the oh, you don't have the height because this would be B. So you would have to use Pythagorean Theorem for it. So on the side, let's do Pythagorean Theorem to get this height here. Okay, so A is 3. You don't know B, but you know your C is 6. Okay, A squared plus B squared equals to C squared. 3 squared plus B squared equals to 6 squared. B squared is going to be equal to 6 squared minus 3 squared, because that's how I'm just solving for B squared alone. B squared is equal, B is just equal to the square root 6 squared minus 3 squared. Very easily, just grab the calculator, square root 6 squared minus 3 squared. You get roughly equals to 5.196, so I could do 5.2. Okay, B is approximately 5.2. I'm only taking the positive value here because this is a physical distance. Okay, so we know that this physical height of this triangle can now be seen as the value of 5.2. So you can do it. The surface area of this object is defined as 4 right triangle plus the lateral area we already have as 216 centimeters squared. Okay, so let's plug this in. 4 times 1/2 the base A times height B plus 216 cm squared. Okay, now let's just plug in the values. So A, we had it at 3, and B, we have it as 5.2. So notice, that's exactly what I'm plugging into my calculator right now. 4 parentheses 1 divided by 2 is the first part. Multiply that by 3, which is the base. Then multiply that by the 5.2, which was the height. Okay, so we get that is the approximately, because again, it's an approximately 5.2. So this is 3.12 centimeters. This is the area of 4 right triangles. Okay, plus 216 cm squared. Notice that these two values are approximately the same, roughly. Do you see how this is 1.18 and this is 1.2? Okay, then you add that together, 216, you get your 247.2 cm squared. All right, in this approach we looked at it from 4 right triangles, because we split this in half. Okay, 1 right triangle, 2 right triangle, 3 right triangle, and 4 right triangle, and we got that answer. Here we looked at it as 2 equilateral triangles, and I got that. The reason why I prefer the 4 right triangles is because I know 1/2 base times height is the area of a right triangle. An equilateral triangle, you would have to memorize it's square root 3 divided by 4 times A squared. But that is how you find the surface area given an equilateral prism.